Good afternoon, class. Today we are going to discuss a case study in material science, which is a fatigue failure of a drive shaft. Okay, there may be many failures that occurs in a moving machine. The major failure is fatigue failure, which usually occurs at the high-speed machine. As the name implies, it's a drive shaft. So these drive shafts are usually used in high-speed machines. So it is obvious that fatigue failure is the major cause for it. So we'll see why it is happening. Okay.
So yeah, coming to the introduction, can be said that the drive shaft is present in the propulsion system of the boat. So it is basically of a drive shaft of a boat. And the broke while the vessel was sailing along the western Canadian coast. So we have taken like when the broke was actually happened, and this part was actually made up of the steel, low alloy steel grade of 4340, and the presence of fluctuating stresses and the presence of stretch riser are the reason for the fatigue fractures. And for the investigation, it was found that the fillet radius present at the fracture's origin was smaller than one provisioned by the design. Although the shaft has been quenched and tempered, its actual hardness did not have the optimal value for a long life fatigue strain. So this is the picture of the broken shaft.
Coming to metallurgical translation, there are three types of chemical compression, mechanical properties, and metallurgical condition. Coming to chemical analysis, the given grade matches with the broken shaft. And similar to tensile, the given requirement matches with the broken shaft.
It's the mechanical properties. Hardness measurements of
Occurs at Rockwell C scale.
Rockwell C scale. The result average will be obtained 30 HRC. And endurance link is already related at hardness, and the values obtained is pinching and temper. As AISI 4340 will reach approximately 30 HRC
And it's tempered. So this is the microscopic examination where you can see it's the tempered martensite, which is done by 3% et al. Okay.
And this is the image of broken shaft. The red color arrow is where the crack begins, and slightly it move inside, and the blue arrow is the crack started in the major part, and that where the blue color box is marked is the broken area of the shaft.
Coming to fractography analysis, it's one of the first feature associated with the fatigue initiation in the presence of the ratched marks. And stage 1 fatigue, in this case, ratched marks were noticed on about 95% of the shaft periphery, and the fillet radius was 1.8 mm, but the required fillet radius is 2.5 mm. So, with this we can conclude that
Stage one
fatigue was due to the heavy work on the machine. And a smaller fillet radius at this location had produced higher stress concentration, which have behaved as stress riser and cause fatigue initiation.
So in this, I have to say one more thing is that there's a stage 2 fatigue, right? So stage 1 and stage 2 fatigue happens due to that. Due to the increases of load condition. Okay, so when a high speed machine, that means a rotor which usually runs at very high speed. Here, due to the fluctuation stress and which is happening due to the sailing part, so that is where the first form of cracks happening. So even though after crack happening, you have to stop the machine and you have to repair it, but most probably you are not doing it. So that the crack once started, it always going to propagate. As our friends say, this is the crack propagate area. And the last part is that it is the crack broken area, that is the shaft broken area. So this is the high cycle fatigue where you can see the crack marks. So this is known as smooth beach marks, right? So this is the low cycle fatigue. Here the cracks are much deeper with some textures. So this is the known as the fatigue textures for the machines. Okay.
Finally, coming to the conclusion, we have concluded that the shaft broke because of the rotating wheel fatigue. And for the grade ASI 4340, the optimum fatigue resistance will be 45 SRC. The fatigue resistance endurance limit will be provided. So thank you.
So here in concluding, before concluding, I have to say two things. So here, if a fracture is going to happen, there will be four types of fractures that usually normally happens in every machine. One is brittle, second is ductile, fourth one is fourth one is creep, and third one is of course fatigue. So you can easily say that if a material is or if a machine or material is if a fracture is happening in a machine part, then you can easily say that we can avoid the other three. It is mainly due to the fatigue. Okay.